In today's episode, we'll break down the technology race that every major country is now treating as a strategic priority: semiconductors. What they are, why the world is fighting over them, and where India fits in. Welcome to Daksham's Deconstruct. I am Karuna from the research team, where every week we pick one big idea and follow the money behind it. Every time you ask AI a question, something physical happens. Somewhere in the world, inside a building the size of several football fields, thousands of specialized chips fire simultaneously to process your request and send back an answer in milliseconds. That physical infrastructure, the chips, the machine that makes them, the supply chains behind them, is now the most contested resource on the planet. More contested than oil, more strategic than steel. And every country in the world is scrambling to control as much of it as possible. This is the semiconductor story, and it is no longer just a technology story. It is a story about power. What is a semiconductor? Let's start at the beginning, because you cannot understand this race without understanding what is actually being raced for. A semiconductor is a tiny chip, smaller than your fingernail, that controls the flow of electricity. Every device you use runs on them: your phone, your car, your microwave, the satellites above you, the hospital equipment that keeping people alive. But the semiconductors powering AI are a different animal entirely. These are chips designed to process billions of calculations simultaneously, not one after another, but all at once. That parallel processing power is what makes AI possible. And here is the critical thing to understand: you cannot download a chip, you cannot 3D print one. The most advanced chips in the world requires a manufacturing process so precise, so complex, that only a handful of companies on earth can do it. And only one company makes the machine that makes it possible. Part 2: the value chain. Think of the semiconductor industry as a relay race that spans the entire planet. No single country runs the whole race. Every leg depends on the one before it. Leg 1: design. Engineers create the blueprint for a chip, essentially a map of billions of microscopic circuits. This happens primarily in United States, with a significant and growing contribution from India. Companies like Nvidia, Intel, and Qualcomm design here. Crucially, 20% of the world's chip design workforce sits in India. Leg 2: the machine that makes the machine. Before any chip can be manufactured, you need a lithography machine, a device that uses light to print those microscopic circuits onto silicon. Only one company in the world makes the most advanced version of this machine: ASML, a Dutch company. Their top machine costs $400 million, roughly 4,000 crore rupees. Just to put that into perspective, there were only 50 companies in Indian markets that did capex of this size. The machine contains over 100,000 parts sourced from suppliers across 3 continents, and the machine itself is the size of a double-decker bus. Without ASML, the most advanced chips simply cannot be made. This is why ASML has become one of the most geopolitically significant companies in the world. Leg 3: fabrication. The actual manufacturing of the chip. This is where Taiwan becomes critical. TSMC, the Taiwan Semiconductor Manufacturing Company, makes approximately 90% of the world's most advanced chip. Not some, not most, 90%. That single concentration of manufacturing capability is one of the most significant vulnerabilities in the global economy today. Leg 4: packaging. Once chips are manufactured, they need to be assembled, tested, and packaged. This is the entry-level part of the value chain. Company here hold the smallest share of overall profit pool, but it is where India is actively building capability. And it matters because every chip passes through this stage before it reaches any device. Leg 5: end use. The finished chips goes into the data centers, phones, cars, defense systems, and industrial equipment. This is where the value is consumed, and where the AI boom is driving demands to level the industry has never seen. Part 3: why the boom? The economics of the supercycle. Here is a number that reframes everything. This year alone, the 5 largest technologies companies in the world, Amazon, Alphabet, Microsoft, Meta, will spend $620 billion on physical hardware, not software, not salaries, physical silicon infrastructure. Amazon's projected spend of up to $200 billion in 2026 alone exceeds the entire US energy industry's annual investment. Why all of this spending? Because AI has changed what computing requires. For decades, computing was about processing one task at a time, faster and faster. AI requires processing billions of tasks simultaneously. That depends an entirely different class of chip, an entirely different scale of infrastructure. And here is the shift most people miss. AI has two faces, training and inference. Training is teaching the AI model, inference is when you actually use it. Every question you ask, every image generated, every decision automated, inference happens billions of times a day globally in real time. And inference requires chips, constantly at massive scale. This is why Nvidia has become what some call the central bank of the digital economy. Their chips are the reserve currency of AI infrastructure, and their software layer called CUDA make those chips nearly impossible to replace. You don't just buy Nvidia hardware, you build your entire operation around it. Switching is not just expensive, it is almost structurally impossible. The industry has made what amounts to $1.1 trillion down payment on its hardware roadmap through 2027. This is not a cyclical boom. This is an infrastructure investment at the scale of building a new industrial age. Chips are no longer a commodity, they are a utility, as foundational to modern civilization as electricity or running water. Part 4: The Five Stacks of AI. To understand why semiconductors became a national security issue, think of the AI economy as a five-story building. The ground floor, energy. At the foundation is energy. Every token an AI produces is the result of electrons moving, heat being managed, and energy being converted into computation. There is no abstraction layer beneath this. Energy is not just an input, it is the building constraint on how much intelligence the system can produce. Before you build a chip fab, before you design a model, you need power. Reliable, abundant, and uninterrupted power. The second flaw: chips. Above energy are the chips. These are the processors designed to transform energy into computation efficiently at massive scale. AI workload requires enormous parallelism, high bandwidth memory, and fast interconnects. Progress at the chip layer determines how fast AI can scale and how affordable intelligence becomes. Designed in the US and India, manufactured overwhelmingly in Taiwan, every major economy is exposed to a supply chain they do not fully control. The third flaw: infrastructure. Above chips is infrastructure. This includes land, power delivery, cooling, construction, networking, and the system that orchestrate tens of thousands of processors into one machine. These systems are AI factories. They are not to be designed to store information. They're designed to manufacture intelligence. This is where the $620 billion is going. The US leads, China is building aggressively, India is beginning. The fourth flaw: models. The AI itself, the large language model, the image generators, the autonomous agents. US companies lead: OpenAI, Google, Meta, Anthropic. China has its own equivalents, and they are closing the gap faster than most Western analysts anticipated. DeepSeek was the moment the world noticed. The fifth flaw: applications. What ordinary people and businesses actually use. This is where economic value is ultimately captured and where every country wants a domestic winner. The critical insight is this: whoever controls the lower floors controls the upper floors. You cannot build a world class AI model if you cannot access the chips to train it. You cannot manufacture chips if you cannot access the machines to make it. And you cannot access those machines if the country that makes them decides you cannot. This is why the US restricted the ASML from selling its most advanced machines to China. It was not a trade dispute, it was an attempt to cap China's capability at a specific floor of the building permanently. China's response was not to accept that ceiling, it was to build its own building. Part 5: Two Worlds Forming. We are watching the global technology ecosystem split into distinct blocks, and the split is accelerating. The first block: PAX Silica. Led by the United States, a coalition of countries building trusted supply chains, semiconductor infrastructure that do not depend on adversarial nations at any critical point. In February 2026, India formally joined this coalition. This is not a symbolic gesture, it is a strategic commitment with real capital behind it. The second block, China's sovereign digital stack. China's 15-year plan has moved beyond economic growth as its primary goal. The new goal is strategic survival, building a complete domestic technology ecosystem that can function independently of Western supply chains. By 2030, China aims for 80% self sufficiency in mature chips. And with 85% control over critical mineral processing, it has a defensive shield that no sanctions can easily dismantle. Xi Jinping stated it directly. Technological innovation has become the main battleground of the international strategic game. This is no longer two companies competing. This is two visions of the future competing. And every country in the world is being asked, directly or indirectly, to choose a side. Part 6, Where India Sits. India's position in this split is still underappreciated, and the underappreciation is the opportunity. India is not yet present at any critical juncture of the global semiconductor supply chain, but it is deliberately building its way in and starting from where it can and moving up over time. Bet 1, Manufacturing. The Tata and TSMC partnership is building India's first major chip fabrication plant in Dholera, an $11 billion investment targeting its first chips by the end of 2026. India is not chasing the cutting edge immediately. It is focusing on 28 nanometer chips, the workhorse chips used in cars, 5G network, and industrial systems. Alongside fabrication, packaging capacity is being built by Keynes and CG Power and Tata Electronics. The Indian government has announced capex incentives of approximately 50% to support this. India is entering at the accessible end of the value chain and building from there. Bet 2, Design Talent. 20% of the world's chip design workforce is Indian. For every major leap Nvidia or Intel makes, there is an Indian design team working through the underlying engineering problems. That talent base is increasingly recognized as a strategic asset in a world where trusted supply chains matter. Bet 3, Pax Silica Membership. By formally joining the US led coalition in February 2026, India has positioned itself as a trusted node in the Western technology supply chain. An invitation for the semiconductor investment that needs a home outside China and inside a trusted framework. The Indian government has backed this with a 1.6 lakh crore of investments through Semicon 2.0. The mobile phone story is the best parallel for what India is attempting here. 5 years ago, India was importing almost every phone it consumed. Today, over 99% of phones sold in India are made domestically. And India is the world's second largest manufacturer of mobile phones. India didn't buy by building the most advanced phones, it started by assembling them and then manufacturing them. Now, it is moving up to making the most components inside them. Through the ECMS schemes, incentivizing large EMS players to manufacture components in house. The semiconductor journey will follow the same arc. Entry through packaging and mature node fabrication, consolidation through design talent and trusted supply chain status, and over time a move up the value chain as capability compounds. So, what's our takeaway? There are 3 implications for investors. 1. This is an infrastructure spending, not a tech cycle. The $1.1 trillion hardware roadmap through 2027 is committed capital from the largest companies in the world. The picks and shovels of this build out, chip equipment, advanced packaging, cooling systems, power infrastructure are as investable as any infrastructure theme in history. 2. India's semiconductor play is early innings, and that is the point. The Dholera plant, the design talent, the Pax Silica membership, these are the foundations being laid right now. Just as the EMS story compounded quietly before the world noticed, India's semiconductor ecosystem is one of the most structurally interesting domestic themes of this decade for patient capital. The world is not just investing in AI, it is retooling the entire global economy onto silicon standard. And in that world, controlling the chips, the machines, and the talent behind them is not a technology advantage, it is a national power.